Okay, so we're going to use this system given here. We're going to solve it using matrices. So we're going to set up our coefficient matrix 2, -3, 2, -2. This time we only have two variables, x and y, and then our answer matrix will be 0, 10. Okay. Now we could certainly find the inverse of this by hand, so we know how to find the 2 by 2 matrix inverse by hand. Okay, however, we're going to go ahead and just use the calculator here, so I'm going to set up my matrices again. I'm going to do my 2 by 2, 2, -3, 2, -2. Okay. So that'll be my coefficient matrix in A. I'm going to go ahead and do my 2 by 1 matrix. My answer matrix is going to be 0 and 10. So I'm going to put that in B. Okay. Alright. And then I'm going to take my coefficient matrix and find the inverse of it. So I'm going to do matrix A, do the inverse. Once again, I'm going to store that in C. Matrix C, that is. Okay. So there's my inverse matrix. We know it's stored in C. And once we have the inverse matrix, we're going to multiply it by both sides of our equation. We know that's just going to give us 1. And when we get finished, we're going to have xy on the left-hand side equals our answer on the right. So let's go ahead and take matrix C. We're going to multiply that by matrix B, which is our answer matrix. And we're going to get 15 and 10. So that means that the point 15, 10, our claim is that that's the intersection point between these two curves, which are both lines, of course. And of course, we can check that as well. Okay, if we do 15 and 10 in here, we'd get 15 here gives us 30. 10 in here gives us 30. 30 minus 30 equals 0, so that works. If we do 15 in here, that gives us 30. 10 in here gives us 20. 30 minus 20 is, in fact, 10. True? Okay. So that works. So we might ask then, when we first started learning how to solve systems of two equations, we learned about graphing. We could graph these two and find the intersection point. Okay. We could solve one for y or x and then substitute it into the other and use substitution. Okay. We could use elimination here. Okay. This one's probably the best elimination one because it's in standard form, both lines. Okay. Or now we have yet another option here. We could use matrices to solve this. Okay. Now with the 2 by 2, okay, is this generally the best way? Probably takes about the same amount of time as the other ones. Okay, but with a 3 by 3, okay, it takes a fair amount of time to eliminate two variables and then eliminate a third variable and then substitute back. Okay, using matrices would probably be the best way, wouldn't it? Okay. And if you had a 4 equation with 4 variables, okay, that's going to be very tedious to do by hand. Okay, and so therefore matrices would probably be definitely the best way in that particular variety. Okay, especially when you have a graphing calculator that'll do most of the work for you, as long as you know what work to do. Fair enough? Okay. All right, so our work today is going to be dealing with augmented matrices and using matrices to solve systems. Okay, so I'm going to give you some time